Hello, my name is Sean Wilkinson, also known as Super3 from Storj, and I wanted to do a informal video on what I've been working on today. So the core premise of Storj is you're able to take your files and store them on this decentralized file storage network. And so this is your file. You take that file and you encrypt it so no one else can read it and access it. And then you distribute it to various nodes. So we distribute it to 3 people, node 1, node 2, and node 3. And we distribute it to multiple people because, let's say, node 3's hard drive fails. Then we can detect this and recover it, send the file to another place from the other 2 nodes that we have. So we kind of have it self-recovering and self-healing if any problems happen with any of these nodes. The other part of that is this check-in algorithm. So we want to be able to verify, not trust, verify that node 1 still has our file or node 2 still has our file and they haven't modified it in any way. And essentially we do this by cryptography and a hashing algorithm. So we can pass a value to node 1. So we pass a value to node 1 that they add to our file to get a unique value, a unique hash. And we already know what that result, we already know what that hash, the number that we generate, the value we generate plus our file equals some value, some unique hash. We already know that value. We generate that before we send off our file. And so we only have to store that resulting value. And then when we want to check that someone else has our file and has a valid copy of our file, we essentially just send the first part. We send the challenge. We send the number that you add to our file. And if they have the file, they can get the result, which we already have, which we can verify. So I wrote a small little Python program that does that here. You can see this is the value that we generate. So we generate this unique value plus our file gets us this resulting value. And we store both of these. So we store this value, this seed value, and the resulting value of this plus our file. Now, we have those portions stored on our system, and when we want to verify that the other person or node 1 has our file, we just pass them this one value, this seed value. And if they have their file, they should be able to generate the exact same result. They should be able to generate this exact same resulting value, which we already have. So let's take a look at this running in code. So this is a file that just has a bunch of filler text in it. So this is an original file, and this is the file that we could be storing. This is a copy of that file stored on node 1, node 2, or node 3. And so you can see that the value that we pre-generated and the value that the other computer or the other node found are exactly the same. But let's just make a small modification to this. Let's add on this other file an extra period and save this file. Now if we run this program again, you can see we passed the exact same seed, the exact same string for them to add to our file. But because we changed that small little period, then these two no longer match. And that's basically the essentials of proof of storage. We can use hashing and a challenge to verify that another person, another computer still has our file because we already know what the end result of that challenge is going to be. So we can take this large file here and reduce it down to not too many characters here. And that's all I really wanted to show you guys today. This code is on GitHub. You're welcome to ask me any questions about this. But that's all I have to show you today. Bye.